Right, so let's do a projectiles question. I'm Mr. Gilbert. A ball is launched at a velocity of 4.47 meters per second at an angle of 66.0 degrees above the horizontal. So right away when I read this question, I draw a picture. Alright, now this isn't to scale, but I just draw an approximate arc, and I draw in theta equals 66.0 degrees, and I draw the initial velocity, which is 4.47 meters per second. So that's all they give us. And I look at this problem, and right away I know I'm going to have to find the components of the initial velocity. Now I might not have to find them both at first, but I know that I'm probably going to have to find something around that. So let's look at question A. How long it took the ball to land. So we're supposed to find how long it took the ball to land. So the time that it takes the ball to land is completely based on the vertical component of the initial velocity. The reason being is that once we separate them, we look at them separately. So the horizontal component is basically just the ball rolling along the ground. The vertical component is the ball shooting up in the air and coming back down. Does that make sense? So right now it asks how long it took the ball to land. Well, we look at the one that is going to tell us how long it takes the ball to land. We're going to look at the vertical component. So it's asking for time, and there's a couple equations that have time in them. There's the distance equation, d equals vit plus 1/2 at squared, and then there's the final velocity equation equals vi plus at. So vf equals vi plus at. Now both of these can be used to solve for the time. This one's a little bit more tricky because you end up with a quadratic. You can solve it, but I prefer this one because it's easier, right? Why do something harder if you can get the right answer doing something that takes less steps and is quicker, right? If you're writing a test, you want to be quick. So we look at this, and to do this we need to talk about what happens when a ball is tossed vertically. So what happens is it goes up, and as it flies up, it's decelerating. Once it reaches its apex, it stops for a second and then falls back down. Not literally for a second, but it stops and then it starts accelerating downward again. So we can say that the final velocity at the top of the peak is 0 at the top of the peak. We know that the initial velocity is the Vy. So what's Vy? Vy is equal to Vi sine theta, like the equation that we were given in class, or it's in our textbook or whatever. So we know that Vy equals Vi sine theta, where Vi is equal to the initial velocity and theta is equal to 66.0 degrees. So Vy is going to be equal to 4.47 times sine of 66.0 degrees, which is going to equal 4.08 meters per second. So that's the vertical component of the velocity. So our question is how long it takes. Well, if the final velocity is 0, the vertical component is, the initial vertical component is 4.08. We know the acceleration due to gravity, right? We know the initial vertical component, and we know that at the apex, the final, so we were talking about the initial at the ground and the final at the peak. So we can say Vf equals Vi plus At, 0 equals 4.08 plus negative 9.08 times t. Now it's negative because gravity is an acceleration downwards, right? So it's always negative. So then t is equal to negative 4.08 divided by negative 9.08. Do you see what I did there? I moved the 4.8 to the other side, divided by negative 9.08, and t was by itself. So our time, therefore, is 0.416 seconds. All right, so we have our time from the ground to the peak. So from the ground to the peak is this long. So from the ground to the peak and then back again is twice that long. So for the total time, it's 2 times 0.416 seconds, which is equal to 0.833 seconds. Okay? Alright, so I was kind of running out of space, so I wrote it on a new piece of paper, and I guess I'll just slide it up as I go. So question B asks how high the ball flew. So what we can look at is, we're still going to look at the vertical motion, right? Because we're talking about the ball going from the ground up to the apex or maximum height. So how high did it go? Well, we know how much time it took for it to go from the ground to the maximum height. We know that the time is equal to 0.416 seconds, right? And we also know that the initial velocity, the initial vertical velocity, was equal to 4.08 meters per second, right? It's asking for distance, so we know we're going to use the distance formula. So distance equals VI t plus 1/2 AT squared, right? So the distance it's going to fly up is equal to the initial velocity, which is 4.08 meters per second, times the time, which is 0.416 seconds, plus 1/2 a, which is negative 9.8, times the time, 0.416 seconds squared. You plug that all into your calculator, you get a distance of 0.85 meters. Okay? So, C, what its range was. So, for this one, we're talking about how far did it go in the x direction. So, now we're worrying about Vx. Right? We're talking about Vx, how fast it's going in the x direction. So, Vx we know is equal to 1.82 meters per second. We know that the total time we figured out is 0.832 seconds. So t equals 0.832 seconds. So we know that we can calculate the distance by just doing velocity times time. So that's equal to 1.82 meters per second times the time, which is 0.832 seconds. So we end up with a distance of 1.52 meters. So it went over 1.52 meters, and it went up 0.85 meters before it came down again. That's all we're talking about, right? So make sure that when you do these questions, you split up the vertical and the horizontal velocity, and your questions are pretty easy after that, right? You just have to keep in mind that you're talking about the right components of initial velocity.